So we are in for a big-time treat. Please join me in welcoming Ariel Waldman.
Hello. Thank you all so much for having me here. This is actually my first time in Kentucky, so I'm really excited. Yeah. So I wanted to actually start with an image that I've recently really fallen in love with. It's this image here. And I just love this image. It looks like this very nebulous, chaotic, almost artistic place. And it looks like something that's very far out in outer space. But what we're actually looking at here is a picture of our own neighborhood, our own galactic neighborhood. This is the Milky Way galaxy. And we just haven't really been able to really see what it looks like for a long time. When we typically think about our galaxy, we typically think it looks something like this, fairly quaint sort of spiral diagram, fairly structured. But when we really look at it, it looks something like this. And we just haven't been able to see it. And that's because so much space dust and space gas gets in the way and blocks our view. And so we haven't been able to really get these gorgeous images of our galaxy for a long time. And these images of our galaxy come from one of my absolute favorite space telescopes, the Spitzer Space Telescope. And it's essentially this telescope that uses infrared technology. So it can peer past all the space dust and space gas and actually get these gorgeous images of what our own home looks like. And it takes these images very much from the viewpoint of Earth. The Spitzer Space Telescope is essentially on an orbit around the sun, similar to the Earth, and it kind of just trails behind the Earth a little bit. And so here's just a few more examples of images from the Spitzer Space Telescope of our own galaxy. And they're just so gorgeous. I don't know, I just have totally fallen in love with them. And so, as mentioned, I'm Ariel Waldman. I live about 27,000 light years away from all of that. So that's where you can find me. These images of our galaxy are very much at the center of our galaxy, and Earth is about 27,000 light years away from them. And so the thing that I love so much when I look at these images is how much it reminds me of how little it is that we know. I think these images came out a few years ago or so, and we actually haven't known that much about our galaxy for quite a while. This is a great image made in 1785 from William Herschel, and this was an early depiction of what he thought the shape of our galaxy looked like. Essentially, you see this like sort of blob, and if you can see very faintly in the middle, there's this dark star in the middle, and that's where he thought Earth might be, in the center of our galaxy. Thankfully, we're not in the center of our galaxy because we'd probably be dead, but this was really great because he made this map of our galaxy using a bunch of star observations. Also fascinating to me is the fact that 100 years ago, we thought our galaxy was the only galaxy in the entire universe, the only one. 100 years ago, we thought the Milky Way galaxy was it. Maybe there were some, nebulas or other space stuff at the edge, but we were kind of the only game in town. And so it wasn't actually until 1924 that Edwin Hubble, pictured here, was able to look at this blob out in the sky and look at it for a long time and determine that it actually was a galaxy and that there was more than just our own galaxy in the universe. We now know, of course, there are billions and billions of galaxies in the universe. And so this blob that he was spending so much time staring at was this. At the time, it was called the Andromeda Nebula. We now know, of course, it's the Andromeda Galaxy. And so he spent a lot of time looking at this and was able to determine that it was, in fact, its own galaxy. Also fascinating because in 964 was the first made depiction of the Andromeda Galaxy, first known made depiction of the Andromeda Galaxy. So in this image, you can see a picture of a person and a fish. These were Arabic constellations. And at the mouth of the fish, there's a tiny cloud. And that's the first known depiction of the Andromeda Galaxy. So it took us about 1,000 years or so to go from depicting this to actually determining that it was a galaxy. I find it also really interesting to think about the Andromeda Galaxy because all of us as technologists and nerds, have become very familiar with it as well. Mac OS X famously shipped with this as its default background. This was the Andromeda Galaxy. So the thing that Edwin Hubble spent so much of his time looking at is something that we ourselves have spent a lot of time looking at as well. So again, the thing that I really love about this image is how much it just reminds me of my love of the unknown and just how much it is that we really don't know about our own universe. And one of the most unknown sort of forces of our universe are black holes. Black holes are these incredibly dense areas of space-time that essentially pull in everything around them, and they have very negative reputations. They are known for being chaotic and destructive, and they'll pull in entire stars and planets, maybe even gobble up entire galaxies. And while that's true, we also now know that they sometimes do the opposite. These black holes essentially gobble up more than they can chew. When they gobble up more than they can chew, they vomit it back out into the universe violently in the form of mixed up space dust and space gas. And this vomit will actually go on to possibly create new planets, new stars, maybe even new galaxies. And so while they are these fairly destructive forces of nature, they're also these incredibly creative forces of nature. And so at the center of our own galaxy, and of many galaxies, there's a supermassive black hole. And not only is there a supermassive black hole at the center of our galaxy, there are as many as 100 million black holes in our galaxy alone. Now, a lot of these black holes are maybe only 2 miles in diameter, fairly small, but still incredibly powerful. And it's exciting to not just think of them as maybe destructive forces of nature, but also to think of them as creative forces of nature. And so, while we can't actually image a black hole because even light itself can't escape from a black hole, we can image a black hole's vomit. And so in this image, this is the galaxy M83, not the band M83. And inside that circle, you can see essentially a black hole's vomit. I'm sure this is all really great during the lunch hour, by the way. So this is an even better image of that process taking place, of a black hole essentially like pulling in everything around it, gobbling it up, but also violently vomiting stuff back out into the universe. And I think why I'm so fascinated with black holes is because, to me, when I think about this process of mashing things up and spitting them back out into the universe to go on to create bigger and better things, to me, black holes are kind of like the hackers of the universe. They essentially sample everything around them, mash it up, and then create derivative works to go on to create bigger and better things in the world. And it's really all about creating sparks that may or may not go on to create future awesome things. So it was actually a spark that led me to where I am today, working in space exploration. In 2008, I was watching this great documentary called When We Left Earth on the Discovery Channel. And it was this amazing documentary about NASA in the 1950s and 1960s, figuring out how they could send a person into space. And I was so incredibly inspired by this documentary that I decided I wanted to work at NASA. And I have no background in science whatsoever. My degree was in graphic design, and I had worked in an ad agency for a number of years. I grew up in Kansas City. And I was so inspired by this documentary that I decided to send someone at NASA an email saying that I was a huge fan of what they were doing, and if they ever needed someone like me, someone without a science background, that I was here. It was totally like a geek fangirl moment, and I didn't ever expect to hear back from them. But serendipitously, I was able to get a job at NASA from that email, and it completely changed my life. And I think one of the reasons why I found this documentary so inspiring is because I realized that a lot of people who created NASA were essentially space hackers. They weren't really rocket scientists. They didn't know a lot about space. They were still figuring it out. And at the time, in the 1960s, the average age at NASA was 26. The average age now is somewhere around 49 or so. So it was a very different sort of environment for NASA at the time. And so I just wanted to share with you a quick clip from this documentary that I love so much about them trying to figure out how to create all these unmanned rockets in preparation for sending a person into space.
To beat the Soviets, NASA must launch a man into Earth orbit. Only rockets can go fast enough.
We knew nothing about rocketry, we knew nothing about spacecraft, we knew nothing about orbits.
I saw a lot of rockets launched. I'd say that somewhere between 30 and 40% of them failed. A lot of them came up off the pad and went the opposite direction. Some of them got halfway off the pad and blew up. Some of them got to 10,000 feet and turned the other way and blew up.
The whole thing crumbled and blew up. It looked like an atomic bomb went off almost over our heads.
We got a big kick out of watching the Mercury astronauts. It was great looking at their eyes.
We're looking at this thing and looking at each other and deciding we want to go back and talk to the engineers a little more before we go further.
And so this is what I loved so much about this. It actually reminded me of this image here. This is what I found just so amazing, is that, yeah, they were still figuring out space exploration. They didn't know a ton about it. And I found that to be incredibly powering, because I watched this and I said to myself, well, I don't know anything about space exploration. I want to work at NASA. And the interesting thing is that when we look at the history of science, a lot of the heroes of science would now be considered amateurs by today's standards. Charles Darwin and Thomas Edison. Charles Darwin was primarily self-funded, and Thomas Edison was really uneducated. He was homeschooled, and he did a lot of his experiments during his night job when he was bored. And I think this is something that we've sort of somewhat lost our way with over time, over the last few decades. We've forgotten that amateurs have been really central to science and also space exploration. So thankfully, today, though, there are a lot of people still running around being amateurs and doing science, which is really exciting to see. SpaceX, which is really exciting for a lot of people, is often pointed to as sort of a beacon of success in space exploration, a coming of age of a new sort of space age, I suppose. And Elon Musk, who created SpaceX straight out of PayPal, essentially poured all of his money and all of his time into building a rocket that would hopefully one day take men into space, men and women into space. And so he poured all of his money and all of his time into this rocket, and he sent it up, and it completely failed. It was a complete failure. And so he didn't want to let that get him down, and so he spent a lot more money and a lot more time doing a second rocket launch, which also failed. So third time's the charm. He spends more money, more time, builds a third rocket, does a third rocket launch, also completely fails. It wasn't actually until his fourth rocket launch that he even had a successful rocket launch at all. And this is what I just love so much about space exploration and hacking and science fiction, is really this exploration of the unknown. I think science fiction has traditionally been really great at this, sort of coming up with ideas before they actually exist in the world. Arthur C. Clarke famously talked about geostationary satellites before they existed, and a lot of other authors talked about things that then later actually existed in the world. And while science fiction is awesome at that, I think hacking, in a sense, can be a new form of science fiction, a way of provoking future things to take place. And so out of this love of exploring the unknown came an event called Science Hack Day. And Science Hack Day is essentially a 48-hour event in which scientists, designers, developers, and all different types of people from all different types of backgrounds get together in the same physical space to see what they can rapidly prototype with science in 24 consecutive hours. And the mission of Science Hack Day is really just to get excited and make things with science. And so here's an image of Science Hack Day from 2011 in San Francisco. This was an event that I had organized. And it's just amazing because you can make something silly, you can make something serious. We don't really care. It's really just around getting excited and making things. It's something where people can just figure out what they want to do, and they might not necessarily know where it's going, but that doesn't really matter. To me, it reminds me of this quote from John Peel, that at the heart of anything good, there should be a kernel of something undefinable. And if you can define it, or claim to be able to define it, then in a sense, you've missed the point. And so it's really just about making all this undefinable things. If it's less about creating products and startups that are going to completely change the world and just be a radical change. If you make that, that's awesome. But a lot of times it's just about playing with things and not knowing where they're going and not caring and just really experimenting. And so I wanted to share with all of you some of the weird, undefinable things that have come out of Science Hack Days so far. So this is a hack that was a lot of fun. This was essentially a lamp that was supposed to light up every time an asteroid passed by the Earth. In a sense, it'd be like a near-death lamp. You could, you could dive under your desk and freak out all of your coworkers. It was a lot of fun. Another fun hack that came out of a Science Hack Day was this one. This was essentially a typeface that someone wanted to create in which all of the letters would have equal wind drag. So what you're actually looking at here is a makeshift wind tunnel, and someone actually recorded the wind drag of each individual letter and then weighted each individual letter so that all of the letters would have equal wind drag. So if you want a typeface in which all of the letters have equal wind drag, it looks something like this. I have no idea what this is good for, but this was a physicist who was playing around with typography, which I thought was pretty cool. Another weird hack out of Science Hack Day was this one. This was called the Deanacary. Essentially, this was a cocktail of extracted strawberry DNA. Now, extracting DNA is something you can actually do fairly simply, but sometimes it requires using materials that are not that edible. So this team actually used all edible materials to extract strawberry DNA. So what you can actually see here is the long polymers of DNA clumping together as they're being extracted. And this is actually a cocktail that's available on Instructables in case you want to try it out yourself. But fair warning, it tastes disgusting. Perhaps one of the weirdest hacks I've ever seen is one where a team wanted to create a thing that would essentially simulate synesthesia. And synesthesia is essentially something where the wires between your different senses get crossed. So some people with synesthesia will report associating certain colors with certain letters, or if they hear a loud sound, they might actually visually see a ripple across their vision. And so this group wanted to simulate what it was like to experience synesthesia, and so they created synesthesia. It's so incredibly creepy. But this mask actually simulates a type of synesthesia. And how this team did this is they essentially took a bunch of vibrating speakers and they attached it to someone's face. And because it was a hack day and they only had 24 hours to prototype this, they needed to find an open pattern for a mask. Supposedly, the only open pattern for a mask that they could find was one for a GIMP mask. And so just going with it, they stayed up all night, sewed together this mask, sewed in all the vibrating speakers, and then they wired it all up to an Arduino and a webcam. So as someone navigates different parts of the room, and different parts of the room are lighter or darker, different parts of your face will start vibrating. So in this sense, you can begin to feel sight and look incredibly creepy while doing it. But I really like hacks that play with this concept of visible versus invisible. And I think why I like that so much is because 95% of everything is actually invisible. And when I say 95% of everything is invisible, I mean 95% of absolutely everything. This is a pie chart of the entire energy and matter in our universe. So as you can see, about 74% is dark energy, about 22% is dark matter, and the rest, less than 5%, is everything visible. In fact, if you factor out intergalactic gas, because how often do we interact with that? Everything visible in our universe is less than 0.5%. So every star you could ever see, every planet you could ever see, anything you can see would then be less than 0.5%. But all of this invisible stuff is really cool. Dark matter is really fascinating. When we look into galaxies and we see that they're held together, there's not actually enough mass to account for enough gravity to explain why they're held together. And so we give this sort of a placeholder name of dark matter. And dark matter isn't uniform. It's actually this stuff that globs on around galaxies and helps keep them all together and helps keep them all close. And so in a lot of ways, this is a very friendly universe. We have we have these invisible, weakly interacting particles that are helping keep us all friendly and keep us all close. But there is also an opposite side to the universe, and that is dark energy. And dark energy does kind of the opposite. When we look into the universe and we see that it's expanding, we actually see that it's expanding much faster than we think it should be. Galaxies are moving farther and farther away from one another. And so this gets the placeholder name of dark energy. And so 95% of everything is invisible. But despite this, we very much have an optical overdose problem in our culture. We often think that if you need more information, we'll simply just give you more screens. This is not a scene from a science fiction movie or an internet meme. This is actually an image from the Large Hadron Collider, the particle accelerator. And particle accelerators do deal with a lot of information. They're essentially these massive space-time smashers. Essentially, they're these incredibly large machines that take subatomic particles and collide them into one another at very high speeds. And when these particles collide, for a moment they turn into energy, and then they turn back into subatomic particles. The difference being is that when they turn back into subatomic particles, sometimes they turn back into really weird ones that we would otherwise only see in the beginnings of the Big Bang or maybe in a supernova very far out in space. So these machines are very much actually creating the nature of the universe and the nature of space-time here on Earth, which is just amazing. But they are also just very expensive machines for scientists to make pretty pictures with. These pictures look something like this. Now, I'm not a particle physicist, so I can't begin to explain everything in this image, but I've been told that the 4 green lines and the 4 red towers in this image represent 4 high-energy electrons. And a group of hackers wanted to play around with the concept of, what if instead of actually seeing visualizations of what subatomic particle collisions look like, what if we could hear what they sound like? And so they created the particle wind chime, which was this amazing device that essentially took subatomic particle collisions and mapped it to sounds. So if you could imagine what a particle collision might sound like, that's what they were actually able to play with. The interesting thing about this is that it was not only just beautiful musically, but this also went on to sort of be looked into as a sort of augmented diagnostic tool for accelerator laboratories. So if you could imagine being at the Large Hadron Collider, which would be very, very cool, but if you could imagine being there and being surrounded with screens telling you how the accelerator is doing. But in addition to that, you could also get used to how the accelerator sounds and get used to if something sounds a bit off. That's what it sort of went on to be looked into as, which was pretty amazing. But despite being the et cetera in the universe, there are a lot of really interesting things to play around with in the visible spectrum. Things like searching for extraterrestrials. The SETI Institute, which is the Search for Extraterrestrial Intelligence Institute, has traditionally looked at radio waves as a way of sort of determining if we could find an intelligent civilization, thinking that maybe they could build a radio transmitter. And while they're continuing to do that, they're also beginning to turn their sights towards sight. They're also beginning to want to look into the universe for pulses of light that could only be created by intelligent civilizations and not nature. And I think it's just really fascinating to think about how alien civilizations might be trying to contact us using a visible spectrum rather than all of the invisible spectrums that are out there. Another interesting way in which we've been using the visible spectrum has been in the search for exoplanets. And exoplanets are essentially extrasolar planets, or planets around other stars. And in our galaxy, there's somewhere around 160 billion to a trillion, very large range, but there's somewhere around that number in our own galaxy. And we found about 900 or so of these exoplanets, or about 900 or so of these exoplanets so far, which is great, but there's still a lot left to be found. And so one of the ways in which a lot of these exoplanets have been being discovered lately is through NASA's Kepler telescope. NASA's Kepler telescope essentially has used looking at starlight very closely. And it looks at this starlight so closely that it's able to detect any tiny dips in brightness in this starlight. And if it detects a tiny dip in brightness in this starlight, it might actually be witnessing an exoplanet passing in front of the star. So if an Earth-sized planet passes in front of a star, the brightness might only dip down by 1/10,000th or so, fairly small amount. But it can detect that and tell you if you found an exoplanet or not. So NASA has a bunch of really great algorithms and essentially machines that can find these exoplanets automatically by looking for all these tiny dips in brightness. But while that's really great, machines are still not as good as humans at pattern detection. And so with that in mind came a project called Planet Hunters. And Planet Hunters is essentially a project where you can go online, look at NASA's Kepler data, and see if you can find any tiny dips in brightness in the data. And if you do, you might actually be well on your way to discovering an exoplanet. The cool thing about this is that if you do discover an exoplanet, and a number of people have already found a number of candidates on this site, your name will go on that scientific paper. This is not work you're doing for some other scientist to take credit for your work. The work you do on Planet Hunters actually gets credited to you, which is pretty amazing. So if projects like this excite you, or at least pique your curiosity, I'd recommend checking out spacehack.org. And spacehack.org is essentially a directory of ways to participate in space exploration. And it's a site that I created when I left NASA. And the great thing about spacehack.org is essentially it captures all of these different projects that you can do with or without a science background to actively further space exploration and scientific discovery, which is pretty exciting. Closer to home, there are some planets that other people are getting very excited about, one of which is Mars, which you can see here. Mars recently gained a lot of popularity last year when the Mars Curiosity rover landed on it. And there are some really exciting things that you can do in preparation for humans perhaps one day going to Mars. There's a great project called the Austrian Space Forum. And the Austrian Space Forum is essentially this group that is trying to do all of this research about spacesuits and space rovers and all sorts of cool space Mars stuff. But they need help from all different types of people to really make their project a success and make it so that we have really great research to use when we do send people to Mars. So the Austrian Space Forum is a great project to sort of get involved in. And they do amazing things like mining caves in Austria, ice caves in Austria, to look for microbes and small signs of life, trying to simulate how we might find signs of life on Mars and how we might maybe one day colonize Mars. But in the meantime, the colonizers of Mars, the early colonizers of Mars at least, might look something a bit more boring like this. This is an image of lichen. And lichen was actually one of the first things to help colonize the Earth a long time ago. Essentially, lichen breaks down bare rock surfaces to give a foothold for future life forms to take place. And so people have actually been able to test types of lichen in Mars simulators and determine that types of lichen can actually survive on the surface of Mars. So before we send humans to Mars, maybe we might send lichen there, and maybe one of the first colonizers of Mars might be one of the first colonizers of the Earth. In the meantime, these will be essentially our colonizers of Mars, these incredibly intimidating Mars rovers. This is an outline that I found online of the Mars Curiosity rover compared to the size of a man. But to me, it looks like that Mars rover wants to murder that man or something. I just don't trust it. And earlier this year, I had the great ability to actually visit one of these prototypes and meet the infamous Mohawk guy from the Mars Curiosity rover. And as you can see, that prototype definitely looks like it wants to kill us. I think rovers, though, could be a lot more interesting than they are. I think there's ways that we could make them more imaginative or more creative. Thankfully, there's a really great project called the University Rover Challenge, which challenges university students around the world to build new types of Mars rovers that might one day be incorporated by NASA or be used in the future. And so students from all around the world participate in this and build their own versions of Mars rovers. And why I think it's so important to be a lot more creative about how we're thinking about rovers is because of things like this. Essentially, I think modeling rovers off of cars can be really boring, and they can have some problems like this one unfortunately did. To me, it's a lot more interesting to think about ways in which we can pull unexpected inspiration from the world and use that for more creative concepts. Things like this. Essentially, this is an image of a tumbleweed. But for the last 10 years or so, a group at NASA has been experimenting with what if we had Mars rovers that would go across the surface of Mars, much like a tumbleweed goes across the surface of the Earth. And so they actually created this prototype. This was an early prototype, I think, in 2002 in Alaska that they were playing with. And they played with this just idea of what if Mars rovers were more like tumbleweeds? And I just love this so much because I think there's so many different ways that university students and people of all ages, honestly, could be contributing their existing creative skill set towards space exploration and making it a lot more awesome. And so this sort of reminds me of my all-time favorite hack from a Science Hack Day. Essentially, the beard detector. This was a really odd device that someone wanted to create at a Science Hack Day. This was a device that would essentially tell this person when they needed to shave or not. And it was really strange. So this guy took this USB microscope and he held it up to his face. And he got this really gross image of all the stubble on his face. I hope you've all enjoyed your lunch. And so he got this really gross image of all these lines on his face, and he wrote some basic code and used an open computer vision library and was able to actually create this beard detector. And here you can see it in action. Essentially, it's saying, no beard found, and then it's drawing lines around the stubble that it finds and telling him when he needs to shave. Now, when I first saw this demoed, I thought to myself, well, that's amusing, but I'm really not sure what that has to do with science whatsoever. But as I said, we kind of just let everyone go and see what they create, and you know, people can create whatever they want at a Science Hack Day. But sitting in the audience and seeing this hack demoed was a particle physicist. And when this particle physicist saw this hack demoed, he said to himself, wow, that's actually a genius way for how to detect cosmic rays in a cloud chamber, which sounds ridiculous until you see what cosmic rays in a cloud chamber looks like. And so following Science Hack Day, this particle physicist wrote this entire proposal for how to detect cosmic rays in a cloud chamber using the original code and open computer vision library someone had used to detect if he needed to shave or not. And this is just what I love so much about hacking and hack days. It's really just about creating future ideas and future collaborations and sparks of future things that are still yet unknown. And so Science Hack Day is actually not an organization. It's just an open set of guidelines for anyone to organize their own Science Hack Day. And so there have been Science Hack Days all around the world. This is an image from Science Hack Day in Chicago, where they got to sort of hack the Adler Planetarium, which was really exciting and fun. This was an image from Science Hack Day in Nairobi that I got to attend, where a lot of people were hacking robots and different mobile technologies, which was just amazing to see. And I wanted to ask all of you here, because this is my first time in Kentucky, and because I really want a really great reason to return, if all of you would create a Science Hack Day here in Louisville. This is something that you can organize yourself, and I'm happy to help you, but I've seen some of the amazing talks here, and I've talked to some of you already, and you're all bursting with creativity. I bet you could come up with way weirder stuff than I've even shown today, and I know you're capable of it. So I think it would be really exciting to see that happen in Kentucky. And so if you are interested in organizing one here, all the instructions are at sciencehackday.com. So with that, I guess I just wanted to end by saying that in space exploration, there's a lot that you could be searching for. You could be searching for extraterrestrials or exoplanets, but to me, it's the search for experimentation that's so incredibly precious. And I think we've found it through hacking science and hacking space exploration. Thank you.
Hi, I'm Jason Ponton. For those of you who didn't see me yesterday, I'm the editor-in-chief and the publisher of MIT Technology Review. I'm going to ask Ariel a few questions, and while I'm doing so, I want you guys to think of the smartest and most provocative questions you can, and we'll ask them of Ariel. As a fellow nerd, I like it that you have a favorite space telescope. Is there a space telescope for whom you kind of feel, yeah, you're just not that into?
That's a good question. I can name all the other ones that I'm into. Admittedly, I'm not as excited about solar space, ones that study the sun, even though I know it's so incredibly important to science and to also our understanding of our own survival. So the importance of them is very high, but I get a lot more excited about deep space, more so than, I guess, the inner solar system. So if I had to say, I might throw the sun spacecrafts under the bus, but I feel horrible doing so because I love all of it.
I'm a space enthusiast as well. Most people who grew up reading science fiction are. But let me ask you the obvious question. I hear this a lot. Why go to space at all? Don't we have sufficient problems on Earth that demand our attention?
That question gets asked a ton, and I think it's a valid question to ask, and I think it's a question that no matter the answer, people will continue asking it. But I always like to remind people that space exploration actually involves people here on Earth, jobs here on Earth. And also, in addition to that, a lot of the things that NASA has done over the last few decades have directly impacted people here on Earth. So the UV coating in sunglasses, that was thanks to NASA technology. Water filtration systems that can actually help people in rural communities, also developed by NASA. So there's actually a multitude of different technologies that have been created by NASA in the pursuit of space exploration that directly benefit people here on Earth. And I think if we took away space exploration altogether, I think we would be losing out on a lot of the technologies that actually do have an impact here on Earth.
Then, of course, there's the less material justification, because it's next. I was very attracted to your conflation of early NASA with current hacking culture. I'd never heard that before, but as soon as Ariel said it, I thought, wow, that's completely true. But you also said that NASA's a little older, and though the Jet Propulsion Laboratory has some of that air of a hackathon to it, I hope you won't take it amiss if I say that NASA seems to have lost some of its way, some of its creativity. And I'd like to ask you why you think that is.
I think it comes inherently with being a government agency. We can talk about wanting NASA back in the early days, and I think we have to come to terms with the fact that that may never happen again, but that's okay, because it can happen elsewhere, and there are ways in which NASA is still really awesome and really great. But it might not be as much in the hacker sort of way like it was, where you have a bunch of 20-somethings figuring out space exploration. But I do think there are little signals of hope for NASA sort of getting that spirit back into it. People are building sort of hacker spaces and maker labs inside NASA centers. And also, the White House has been incredibly embracing of hacker culture and that spirit. And so while, yes, it may have lost its sort of hacker spirit over the last few decades, I do have hope that it'll at least incorporate a significant portion of it back into it. And I think there's just, you know, as we all do, you have to come to terms with things change, and that doesn't necessarily make it bad, it just makes it different.
There was a great hacker moment when the Jet Propulsion guys got the old, smaller rover, which is still working on the surface of Mars, and they drove it to reunite with Discovery. It's like a moment in a movie. You can imagine it cresting the crater and seeing its colleague. I know as a member of the Human Space Exploration Committee, you can't express a preference for any actor in the field, but you talk about a government agency, NASA, getting older, but I guess the question is, without expressing a preference about Elon Musk or any private space company, do you think that private industry can do some of the creative things that NASA used to do?
I think a lot of people are really looking at how people in the private space industry can play larger and different roles, and perhaps more creative roles as well. I think it's really interesting to see everyone's excitement about the different aspects and see people's excitement about almost the different brands that these different space companies have and the different personalities behind them. I think a lot of that points to perhaps a public craving for new creativity in space exploration. But equally, you see people getting really excited about the Mars Curiosity rover. So I don't know, I think the exciting thing for me really is just to see people getting excited about space, whether it be a robot or a human or whatever. I don't know, to me it's incredibly awesome. And I think a lot of people like me just would never consider in a million years that they could work at NASA or work at SpaceX or work at Virgin Galactic or any of these companies. And the reality is that you can, or you almost can in the next few years, because it's really opening up. And I think people realizing that and realizing that they can actively contribute to space exploration really means that you're going to have this influx of creativity from everyone actually realizing that they can do stuff in space exploration, which would be incredibly cool if they knew it. And I think people are slowly but surely realizing that.
We have time for some questions from the audience. There are mics here and here. Line up and please say who you are and where you're from. And though short statements are acceptable, questions are so much more polite. Please.
Okay, you wanted a provocative question. Here's one. My name's Jens Hanneman. I'm an engineer, electrical engineer actually, and teach computer science at Kentucky State University. Yes, I know. He made me say it, right? However, so if you love science so much, why didn't you study it?
I actually wasn't interested in science at all growing up. It was boring to me, and I don't blame my school or my teachers for that. I just wasn't interested. I was obsessed with design, and from the time I was 14 years old, I knew I wanted to be an executive creative director, and that was what I was going to be. And so I spent 8 years in an ad agency working towards that goal, and I went to school for design, and I loved it. And I don't think anyone could have possibly pulled me off of that path. And so this is why I guess I feel like I'm on this mission now since 2008, since getting this job at NASA, to get other people excited about science and space exploration. Is I think there is so much focus on getting small children interested in science, which there absolutely should be. But if you go to school, if you choose a different career that's not in science, the science industry inadvertently kind of says, well, you're forever lost to us. There's nothing you could do now. If you want to get involved in science later in life, go back to school, that's how you can do it. And I think that's just incredibly wrong. And I think people who have interests in different areas are just completely overlooked by science. And it really upsets me, because there are ways in which you can contribute your existing skills and your existing sort of background and apply it towards science and space exploration, that's really interesting. So I'm not trying to convince people to necessarily stop everything, change their careers, go back into science, go back to school, and go to school for science. I'm telling them that where you are right now is totally awesome, and you should just apply yourself occasionally to space or science. And I think the science industry could really use that.
Hi, my name is Chase Grimes, and I'm currently enrolled as a student at DuPont Manual High School, and I'm studying vocal performance at YPAS. It actually kind of pertains to the last question, because one of my other passions is theoretical physics. And
it's awesome.
I know that one of the biggest issues in physics in general was the unification of the theory of relativity and quantum theory. And with the discovery of the Higgs boson particle and the discovery of the temperature below absolute zero and stuff like that, it just seems like there's been a wave of recent interest in physics, and I really, really dig it. And I was just curious of your thoughts on the unification of relativity and quantum theory, and whether or not you thought string theory would be a good candidate for that, and if you had heard of the recent development in quantum theory of the discovery of the amplituhedron, and how that might affect anything. So,
I think you are out-sciencing me at this point. It's epic. Like, but I will tell you what I am really excited about, and string theory is definitely on the experimental theoretical side of physics. So there is a lot of people who are totally against it, and some people who are like, this is going to be it. And that's fascinating to watch. To me, the thing that I've actually found most interesting in physics is the idea of multiverses. And multiverses is really cool and really interesting because it sounds like something completely out of science fiction that, oh, of course, you know, we only knew about our own galaxy 100 years ago, and now we know there's more, and there's always going to be more. So of course there will be multiverses. But it's actually not that set of thinking that has led scientists to think about multiverses. If you look at the math and the physics, it actually makes more sense scientifically that there are multiverses. And so a lot of scientists who would love to oppose this sci-fi concept of multiverses are actually now embracing it. And that's just amazing. And I think there's just a lot of really cool things happening, I think, in the next decade or so that are going to bring to light this whole search for if we could ever discover multiverses. And we might not ever be able to. There might be no way of ever seeing them, which could be very likely. But there are really cool things like the microwave background, the cosmic microwave background, which is essentially the baby picture of the universe. There's these great pictures that show the universe, what the universe looked like when it was only 300,000 years old or so. So essentially these baby pictures. And people are trying to see in this cosmic microwave background if they could see any inklings of a multiverse maybe pushing up against our own universe, which is fascinating. People have thought that they've found it, but so far it's been proven to be inaccurate. But as we continue to get more data, people are going to look into this and see, is there any possible way we could ever prove that there are more universes than our own? And to me, that's actually going into the theoretical physics side of things. That's the side that I get really, really excited about.
I love when they, great question. I love when they debate how many multiverses there are. They get very specific. 1,114. Please.
Jenny Wu. I'm a student at the University of Kentucky, and I just kind of wanted to hear your thoughts about the development of the kind of culture of creativity and contribution that we were talking about. I thought it was interesting that you mentioned the early NASA culture when they were all in their mid-20s and now in their late 40s, but it seems like there were a lot of instances you were talking about where they were encouraging people outside of science to contribute, and also movements with universities. I know at the university I go to school at, our electrical engineering department has been working on making a satellite that's going to be sent to NASA and it's going to actually be put out into space. I think things like that are really awesome. And so what I was thinking is, how do you think that kind of culture develops, and how do you think we can generate that kind of creativity? How do we create people like space nerds only in different areas of science, and do you think it's possible to move that kind of culture outside of science?
Yeah, so first off, if you end up building a satellite, which it sounds like you are, that's really, really cool. Oh, well, all of your friends are really, really cool. You should hang out with them more. Yeah, getting that creative culture, a lot of it is, surprisingly, unexpectedly simple. A lot of it is about just getting everyone together in the same physical space and getting the space nerds together with the art students and getting the art students together with the scientists and putting them all in a room together. When I organized the first Science Hack Day, which was, I guess, 3 years ago in San Francisco, I was so terrified because I had organized this entire event and we had all these different types of people coming and a lot of them didn't know each other and I had organized everything to a T, but I was losing sleep every night because I was terrified. I was like, I can't control if anyone will actually like each other or even want to talk to each other or think each other is boring or hate each other or say, oh, I don't want to work with that person, they're weird. I was like, oh my God, I can't design for this. I can't control this factor. I was freaking out. And somehow, magically, just getting everyone together and saying, let's see what we can prototype. There are no barriers. You don't need to know anything about particle physics in order to play with particle physics data. You don't need to know anything about space to come up with weird satellite ideas. I'm sure all of you could come up with weird satellite ideas. Who cares if they're scientifically viable or not? That's not the point. Is getting that creativity can actually go on to actually influence science in real ways by getting all these different people together. So it's not the most unique idea, but honestly, getting all these people in the same room, never underestimate that. That's really, really important, and it will honestly surprise you because every year I'm always terrified about like, God, what if no one will like each other or just, all the ideas are boring and but every year there's no way I can expect something like synesthesia or the de-anacary or all that weird stuff. People will come up with weird things, and I think the most important thing to remind everyone is that you don't need to have a background in science. You don't need to have hacker skills. You don't need to have any of that. Just take yourself as you are and just come up with weird things with other people over the course of a weekend. That's really the joy of it, and honestly, I have never seen it not work, I'll say that.
Hello, my name is Daniel. I'm a fellow classmate of Chase. I also go to DuPont Manual. I started a theoretical physics club there, which has been going on, well, we started last year, and every week we've discussed amazing topics from Newtonian physics all the way to string theory. So my question also involves string theory. Do you believe that S particles could ever be connected with dark matter to leading, maybe they're invisible or something like that?
I think that's, obviously no one knows this yet because we haven't actually discovered dark matter. I think it will be interesting because it really feels like we're closing in on what dark matter could be. Every few months there's some new experiment where like, have we discovered dark matter? And it's like, oh no, and everybody gets sad. But I think dark matter, I think and I hope we will discover what dark matter exactly is soon. I think it's actually something that I think is a lot harder for people to come up with what it might be is dark energy because it is more uniform. It's not easily as measurable as dark matter is. We can get these great sort of diagrams of where dark matter is. Even though we can't see it, we can measure the effects of it. And so dark matter colliding with string theory would be huge, but I think it kind of may overlook the fact that string theory is still this huge ball of string that we haven't really unraveled yet, and people are still sort of debating different types of string theory. So I think we might not necessarily see that they're connected, but I do think there will be interesting things that open up as we continue to close in on dark matter, and I think a lot of the work that's been done on the International Space Station in Antarctica will really be able to start unraveling that more.
One last question, please.
Hello, my name is Gabriel Draper. I'm a PhD student in chemical engineering at the University of Louisville. And oftentimes when I'm doing my research, I'll stop and I'll just be like, oh, I need a new thing to hold my silicon cells. I'm wondering if you ever just start hacking things in your real life on your day-to-day basis?
I often, the thing I probably personally create more often than not is just stupid websites. You know, I have weird ideas for, you know, either taking science stuff and then putting it into a more sort of artistic format, or just coming up with weird resources that are useful. So for me, I think the web has always been something I like sort of hacking around with as I can. The thing that I'm always so sad about with running these science hack days is when I'm running them, I have no time to hack myself. So that asteroid lamp that I showed in the beginning was actually an idea that I had for a hack, and I didn't have time for it. But thankfully, I'm friends with this open source rocket scientist, as everyone should be. His name's Nathan Berge, and so he came to Science Hack Day, and I told him about this hack idea that I wanted to do, and he actually ended up building it and putting it together using like plastic cups and like all different weird things, you know, really hacked it together, which was amazing. And then even afterwards, that influenced him to create this great little device that would essentially detect whenever the International Space Station was overhead, and it would light up. And he did a Kickstarter for that, and it got funded, and it was really awesome to see. So if I had more skills, I'd probably do more hardware hacking than I currently do. I take Arduino classes when I can, and I take like Python programming classes when I can. A lot of time, though, I think I probably default to hacking stuff on the web, because that's what I really enjoy. So this is what I always try and tell people, is that I'm not a scientist, and I don't really have a lot of hacker skills whatsoever. I just play around with things, and that's why I try and tell other people, you know, it's really just about being confident in who you are, and the fact that you can come up with amazing ideas even if you don't know a lot or have a lot of hacker skills to do all of this. So thanks for your question.
I want to say that the questions from the students of Louisville over those last 2 days have been absolutely awesome. So you guys are great. And on that note, another warm round for Ariel Waldman.